This is your physics review for the first exam, motion. This is the answer key as posted. I just thought I would comment with a few things to add on. An object moving at constant acceleration. That means that its velocity is changing by the same amount in equal time intervals. So in other words, in every second, the velocity changes by the same amount. Speed does not include direction, so that is not the best answer. In equal times, it moves equal distances. Now that would be describing a constant velocity, not a constant acceleration. If you look at a graph of acceleration versus time, if you have a constant acceleration, then that is just some constant value. It could be a positive value, it could be a negative value, but that is a constant value. Its velocity is changing by the same amount in the same time interval. Remember that acceleration is not the same as velocity. They have different units. Velocity describes how quickly the position is changing. Acceleration describes how quickly the velocity changes. If you have a constant velocity, then your acceleration would be 0. If your velocity changes by the same amount, then the velocity is changing in a regular way. You would get that graph, velocity time graph, that has a slope to it. In the case that I drew here, that's a positive slope. That means that the velocity is increasing as time goes on, and that would match with the acceleration graph that is drawn above it. The second one, the ball is thrown straight up, reaching a maximum height and then falling back to its initial height. On the way up, it is slowing down. It's getting ready to reverse direction. So remember, if it's moving up, that's a positive direction, and moving down would be the negative direction. If you are going from a positive velocity on the way up to a negative velocity on the way down, you have to pass through 0. The object is actually stopped at the top of the path. As the ball is going up, those velocity vectors are getting shorter and shorter. That means the acceleration vector has to point down. You would have to push down that bottom vector to turn it into the next vector. Remember, you're always changing the first vector to turn it into the later vector. Turn v1 into v2, for instance. Never the other way around. If velocity and acceleration both pointed upward, then you would have velocity and acceleration arrows, vectors, pointing in the same direction. That object would be speeding up if A was correct, which it's not. C, if the velocity pointed downward and the acceleration pointed upward, if velocity pointed downward, it would be moving downward. It's not moving downward, it says as the ball is going up. If the acceleration pointed upward, you'd have velocity and acceleration in opposite direction. The object would be going downward and slowing down, which is not what would happen with the ball dropping. If velocity and acceleration both pointed downward, the object would be moving downward and speeding up, and that's just not consistent with the ball going up, the underlined portion. Number 3, an object moving with constant non-zero velocity in the x-axis, position versus time graph. If you have a constant non-zero velocity, it's either going to be a constant positive or a constant negative. If it was constant positive, you'd have a positive slope. That means that as time goes by, the position is moving more and more to the right. If you had a negative velocity, that would mean that you'd had negative slope and it was moving more and more in the negative direction. Again, how do you find velocity from a position time graph? It is the slope of a position time graph. Constant velocity means that the slope is constant. What kind of shape do we draw for a constant slope? A line. The area under curve acceleration versus time gives the change in velocity. It gives the change in velocity. So look at that acceleration time graph. You have a constant negative acceleration in this particular case. The area enclosed gives you the delta v. We can get this from the equation acceleration equals delta v over delta t. That's definition of acceleration. If you solve that for delta v, you're going to get acceleration times the time interval. Essentially, what is the acceleration and for how much time is it accelerating? Is its velocity changing in that way? If you look at the units there, you get meters per second squared for acceleration and seconds for the time interval, and multiply those together, seconds on the top, seconds squared in the bottom, you'd end up with meters per second. Those are the units for delta V. The units will really, really help you if you work through them. Another way of saying the area under the curve there, well, that's the area of a rectangle. The area of a rectangle is base times height. What is the base? Well, it's the time interval. What's the height? It's the acceleration value. So the area under a curve, that just means the area enclosed between your shape and the x-axis or the horizontal axis gives you how much velocity changed. Just comes from the definition of acceleration equals delta v over delta t. Velocity time graph of an object in a straight line, then that object must be moving with a constant non-zero acceleration because the velocity is changing. If it was moving with a constant non-zero speed, then you would just have a velocity graph that is a horizontal line. If it is at rest, then you would have zero velocity. Moving with infinite speed, I will not give you anything with infinite speed. That would not make sense. So that horizontal line would be what would be true if answer choice A was correct. That's what a velocity time graph would look like. That would be the blue line is showing constant non-zero speed. The red line that I just drew in there is showing at rest. If you are at rest, then your position does not change, so that means that your velocity is zero. Car is traveling at 90 kilometers per hour. That is its velocity. How long, that's asking us for a time, does it take to travel 400 kilometers? So you can get this from one of the four motion equations or from the definition of velocity or from our understanding of 90 kilometers per hour means that every hour you travel 90 kilometers. So we have an answer of 4.4 hours. Check it with our equation, v equals delta x over delta t. So I think I know what it is. Check and see whether it does in fact give the velocity. Kind of plug it back in, the same thing you've been telling you to do in math class for a long time. So we know the displacement is 400 kilometers per hour. We think it's going to take 4.4 hours. Divide those and you get 90 kilometers per hour. So it's all matching up. Number 7. Cart with an initial velocity of 5 meters per second experiences a constant acceleration of 2 meters per second squared. What is the cart's displacement during the first 6 seconds of its motion? Look at that picture representation. It has everything labeled. x0, v0, t0, x1, v1, t1, delta x, delta t, and what the acceleration is. Every single variable, not just the ones that appear in the problem. Only 3 numbers appear in the problem, but you have 9 variables listed. So we need to know the displacement, that's delta x, and for a time interval of 6 seconds. We know the initial velocity, that's vi in the equation, and we know what the acceleration is. That means that it is accelerating. Its velocity is changing by 2 meters per second every second. And so your motion equation gives you that it must travel a displacement of 66 meters for that to happen. VIT plus 1/2 AT squared. Please make sure that you have physically typed the number into the calculator and hit enter. Do not just assume that that's right. You want to fix any calculator mistakes now and not encounter them on the test. Another calculator note, you can type this all in one line in your calculator and hit enter. I do not need to see what 5 times 6 is. You can just hit 5 times 6 plus 0.5. I usually just type in 1/2 is 0.5 times 2 times 6 squared. Please be very careful about those squared signs and then hit enter because you didn't need to rearrange anything on this particular problem. A bullet moves horizontally to the right with a speed of 500 meters per second, and it hits a sandbag, penetrates a distance of 10 centimeters. Get those units right to meters and seconds right away. What is the average acceleration of the bullet? So again, we have a motion diagram with everything labeled. I guess delta t is missing there. Choosing motion equation, you have vf squared equals vi squared plus 2a delta x. You know everything in there but the acceleration. There's one small error. This math does, when you do 500 squared and then 0 minus 500 squared, that does turn out to be negative. So that did not magically become negative in the answer choice. The math does give you a negative sign there. Motion diagram for this, we're assuming that it's moving to the right because that usually makes things easier. Those vectors are getting shorter. The acceleration vector is to the left, and that is consistent with the negative math result that we get there. What is the acceleration at 1 second? Let's look at that graph for velocity versus time. Please make sure that you're always looking at the axes first before you do anything. Very important, whether it's a position time, a velocity time, and acceleration time. So at 1 second, the acceleration will be the slope of the velocity time graph at that moment in time, so at 1 second. Because it is a straight line between 0 and 2 seconds, you can choose any convenient points. Probably what would be convenient, because they're easy to read off, would be 0, 0, and 2 seconds, comma, 20 meters per second, right? 0, 0, and 2, 20. So what that means is that the rise is 20, the run is 2, 20 over 2 is 10 meters per second every second. You could also have chosen 0 and the 1:10 point there, 1 second and 10 meters per second. Same thing, as long as it's moving in a straight line, you can choose any two convenient points. We would expect, our math did give us a positive acceleration. That's what we would expect there because that velocity time graph has positive slope. Just continue, not answering the question, but just continuing analyzing that graph. Between 2 and 4 seconds, that velocity is constant. It's at a constant 20 meters per second. That means that the velocity does not change. Between 2 and 4 seconds, the acceleration is 0. The velocity does not change. That's what zero acceleration means, is that the velocity is not changing. And then between 4 seconds and 6 seconds, the velocity is getting closer and closer to 0. So it has a negative acceleration, negative slope. Velocity is positive, acceleration is negative. It is slowing down between 4 seconds and 6 seconds. Between 6 and 8 seconds, it actually starts moving to the left. It starts moving faster and faster to the left between 6 and 8 seconds. That's what negative velocity means, is moving to the left, not in the positive direction, but in fact in the negative direction. It is continuing to accelerate between 6 and 8 seconds. The acceleration vector is still negative because that's still negative slope. In this case, between 6 and 8 seconds, you have a negative velocity, a negative acceleration. It will be going faster and faster in the negative direction. Remember that negative acceleration does not necessarily mean slowing down. You have to put it together with the velocity to see whether it'll speed up or slow down. The displacement from 2 to 4 seconds, the area under the curve for a velocity time graph is displacement. So, and you can get that the same kind of logic that we did on the velocity, the acceleration time graph, the area under the curve. So that would just be the area of that rectangle. So base times height, 2 seconds, times 20 meters per second. 2 times 20 is 40 meters per second, times seconds gives you meters. Once again, carry the units along with your calculation, and it definitely pays off. This would be a positive displacement because the object was moving to the right. It's on the positive side of the axis, but also the object was moving to the right. I hope this helped. Feel free to rewind the parts that you need to, maybe listen to again, and please message me with any, or email me with any questions as you are studying. I can usually get to those at some point during the day. Good luck!